UTM Sanjangan Bansa. We are from Team Blue Whales. And me Lu Jinwei as the team leader with my members. Michael and Tam would like to greet everyone with our most cheerful countenance. First of all, have you ever heard about microplastics? What is the impact of microplastic toward our nature and human life? As the increasing production and usage of plastic products, in this age, Malaysia generating a staggering 0.5 kilogram to 0.9 kilograms of municipal solid garbage per inhabitant per day, where plastic waste has been making up an estimated 25% of the total. The hidden danger of microplastics have been started to pose a significant threat to aquatic life, agriculture, human health, and sustainable development in Malaysia. Well, what is microplastic actually? Microplastic is the extremely small pieces that less than 5 millimeters of plastic, where it can be everywhere found in our oceans, ecosystem, food chain, air, and human bodies nowadays, as microplastic is not biodegradable and very difficult to be removed from contents, thus it is very dangerous to all organisms. By taking this issue as a responsible, an innovation had been designed by our team, which is a hydrocyclone with laser-drilled filter. Hydrocyclone is a conical-shaped device that helps to separate denser microplastics and less dense microplastics. When wastewater is flown into the hydrocyclone, the wastewater will strike the conical wall of the device and be forced to spin downward to the narrow spigot due to the gravity and release out the denser microplastic. Since the narrow spigot would prevent the wastewater to flow out in one go, hence the upward vortex would be produced that brings along the less dense microplastics to flow out through the upper outlet. Meanwhile, the laser-drilled filter is a container that has millions of micrometer holes on it that helps to collect the separated microplastics up to the size less than 10 micrometers. The laser-drilled filter will be putting in the pipes that connects both upper and lower outlets of the hydrocyclone. One of the reasons the combination of hydrocyclone and laser-drilled filter was chosen is that it helps to facilitate in collecting and recycling back the microplastics into different types of plastic from the river and surface seawater. There are 5 criteria that have been putting into consideration when designing this innovation, which are innovativeness, economic value, effectiveness, environmentally sound, as well as technical feasibility. For innovativeness, the combination of hydrocyclone with laser-drilled filter is a new combination and yet to be available on the market. The hydrocyclone device helps to separate denser and less dense microplastic waste in the wastewater, while the laser-drilled filter with millions of micrometers holes helps to collect the separated microplastics. It facilitates the process to recycle back microplastics from the wastewater. For economic value, it would cost RM1 3-to-1 or more with a household size of hydrocyclone with laser-drilled filter. This product also does not consume a lot of energy, as hydrocyclone can create cyclone by the geometric structure itself without the need to supply energy, and it is easy to maintain. For effectiveness, hydrocyclone with laser-drilled filter is able to separate finer particles, up to 98% separation efficiency. It also works fast, as it only needs an average of 1.5 seconds for the wastewater to reach to any 2 outlets. For environmentally sound, hydrocyclone with laser-drilled filter is very useful in cleaning rivers and the surface seawater. It does not damage the aquatic flora and fauna, and due to its less energy consumption, energy waste and radiation can be avoided. Lastly, for technical feasibility, a device combined of a few pieces of this hydrocyclone with laser-drilled filter to make a bigger device is efficient in cleaning the seawater surface in a larger scale and greater speed. Therefore, the whole country will be benefited. In conclusion, this study provides an overview of the problems with microplastic in the environment and the suggested product. Hydrocyclone with laser-drilled filter as one of the alternatives to solve the problem. In order to achieve the Sustainable Development Goals of 7, 12, and 13, SDG 7, which is affordable and clean energy, has been achieved. As hydrocyclone with laser-drilled filter is low energy costed. Due to hydrocyclone can create cyclone automatically. With its conical shaped geometric body structure as well as the product is also easy to maintain. Apart from that, SDG 12, which is responsible. Consumption or production can be achieved through community involvement. In popularizing this innovation and willing to contribute fund for the greatest implementation of this innovation. Lastly, SDG 13, which is climate action, is achieved as burning of plastic will be reduced and, as a result, less carbon dioxide gas CO2 will be emitted and global warming can be reduced. Also, the ocean will be able to get rid of microplastic as more as possible that gives us back the clean and safe water. And that concludes our presentation. Thank you for watching.